Um, good morning, good afternoon, good evening, everyone from where you are around the world. So welcome to our next Starburst in Action webinar. Today is our guest is George Karapalidis, Director of Data from Checkatrade. George will walk us through the journey he and his team have been on to modernize their data platform with Starburst. The webinar will take 30 minutes. Please feel free to put your questions into the chat and we will try to answer immediately or in the Q&A section after the presentation. Over to you, George.
Thank you so much, Nathan, and hello to everyone who is with us today. So today we'll discuss the partnership with Checkatrade and Starburst. We will focus on three important topics. First of all, the company, who we are and what we do. Then we will dive a bit deeper into the architecture. For some of you may be very familiar and not so complex. For some others may be extremely complex, but we will find out. And then eventually we will discuss why Starburst and various user stories that we were able to satisfy towards our vision to democratize our data platform. So who are we? We are Checkatrade. We are UK's leading platform for home improvements, and we have been connecting consumers and tradespeople for over 25 years, for anything that has to do with their properties, from fixing a leaking tap all the way to building a new house. We facilitate over 3 million jobs, a £7 billion of business for small and medium-sized enterprises annually. We have evolved over time. When we started, we were just a paper directory going door to door. Of course, we developed an online presence and we have achieved a huge amount of success. But the past couple of years, we're trying to become a tech-driven marketplace by developing seamless experiences for connecting our two entities, consumer and trades. Those two entities individually are extremely complex, and when you bring them together, the complexity increases exponentially. So it's not as simple as it sounds. And to be honest, we are accepting the challenge and we're trying to do our best in this area. We want to continue building upon our long-lasting commitment to high-quality trades, because this is what has made Checkatrade the #1 platform in the UK, and we want to continue building on this reputation. Our data platform architecture has been in the making for over 6 years. Before I jump into the detail, I want to set up the scene a bit by giving you some stats, just for context. We ingest over 120 data sources that can be real-time, near real-time, hourly, or even daily. We have over 100 lines of SQL code. This is extremely important for a user story that I will explain a bit later to you. We have over 500 Airflow DAGs that process thousands of tasks and process daily. We process over 100 terabytes of data, and we have connected over 44 catalogs on our Starburst environment across multi-region and multi-cloud. Multi-cloud is the future, and it's very important to be able to be in a position where you have the flexibility to connect data across multiple platforms. We have developed and materialized over 2,500 data tables for our end consumers to consume. We have built over 300 reports and dashboards for more or less everyone in the business, not us as a data team, but because we have opened up the platform to others as well, other people can create their own dashboards and deliver insights to our users. The beautiful thing that we achieved with Starburst since we started our partnership over a year and a half ago is that we open up the platform to our users for over 30% of our business to direct access the platform, meaning writing SQL code in a self-serve manner. And of course, we have over 80% of our business who consume BI solutions and BI dashboards with already pre-aggregated metrics, because we try to deliver insights to them in daily basis. We are a highly data-driven business, and we're using data to back up more or less any decision. As I said, our architecture has been 6 years in the making. The core philosophy hasn't changed, has been always the same from the beginning. It's a data lakehouse architecture that tries to unify all the data the organization generates and consumes. What you see here, for some of you may be very familiar or maybe too complex, but what I want to highlight is the 7 critical pillars for a modern data platform, from all the way the sources that we ingest and the different types, the different methods we're using to ingest and transport data, our storage layer, which is currently on AWS S3 as a single source of truth, the way we query and process, and of course, the different levels of transformation that we apply to our data, from creating metrics to the medallion architecture, all the way to delivering gold datasets for our users to analyze in a self-serve manner. Of course, we're satisfying a lot of different use cases when it comes to analysis and output, from BI, embedded analytics. We augmenting our data with LLMs for providing contextual information, or for example, running classifications on the fly. We have a lot of AI and ML capabilities as well, and we have built a lot of systems and processes to improve the various experiences and products that we deliver to the business. What I wanted to highlight here is that Checkatrade, since we onboarded them, one of the things that we had to do is to think its role within our architecture. And currently, Starburst touches more or less every single one of those boxes, either directly or indirectly. Either because with Starburst, we govern all our assets and users for everything that we have available on our platform, or because we're using Trino as the SQL querying engine, part of the managed service from Starburst that we run to process any of our data, or because of the connectivity opportunity that Starburst has provided us with, where we can connect directly to various critical sources natively within the platform. So Starburst has become extremely critical to the operation of our architecture and has enabled us to do a lot more that we will discuss in a bit. The key principles of our philosophy behind how we approach our platform can be represented by this simple flow. We wanted the platform to be reliable, scalable, and modern, of course, as everyone wants it to be, because the goal is to enable self-serve. We want as many users as possible to have direct access to our platform and be able to analyze and play with the data at their own pace as they see fit. Because the ultimate goal is the more people we have playing with the platform, access to the platform, and trying to extract insights on their own way, what this allows us to do is we externalize knowledge, and by making them comfortable with the platform, that means that they can go faster, and thus is what I call making our users superhuman. Because I want them to see the solution end to end, because they know what they want to achieve, they know what the data is, how they can analyze it, and completely in a self-serve manner, they can get all the way to the end by themselves. And this is my definition of superhuman. Now, let's talk about why Starburst. We always used Trino, previous versions of Trino from the beginning, 6 years ago. So it was, for us, important to continue building with it because we really like it. And it was obvious that we wanted a very strong partner that can provide us a very strong managed service for Trino, simply because we wanted to reduce DevOps overhead to the minimum. So as we were discussing what the new solution should provide for us, it's a single solution that can help us bring data together with ease, scale processing, usage, and control fast, where anyone more or less can do it, provide a safe environment for all the hundreds of users that we have to play, learn, and experiment without worrying or us micromanaging how they use the platform. And of course, as I said, to minimize DevOps overhead as much as possible. The goal was always to give the platform back to the people who built it and maintain it. And these are the data engineers, because the closer they are to the platform and the closer they are to the users at the same time who use the platform, they can provide an exceptional level of support and guidance on how they can use the data and what they can achieve. At the same time, as we were trying to achieve all those different needs and meet those requirements, we wanted to continue building with Trino because we love it, and our code base was already Trino ready. We wanted to be cloud agnostic, because in this day and age, you never know which cloud platform will come up with a revolutionary technology that you want to at least have the opportunity to try, that nothing locks you in an environment where you cannot really explore easily with your own data other technologies. And of course, when we're talking about cloud agnostic and lots of different platforms, that increases complexity. So we wanted a solution that will allow us to reduce our architectural complexity and achieve the end result as fast as possible. At the same time, because the goal was always to open up the platform to everyone, it was very important to us to provide them with a reliable platform that feels like a highly available service. Even though at core, we're a reporting service and our primary job is to deliver data and insights to the business, because we wanted to open up the platform, our users had to feel that the platform is reliable. It's always available because they can query data anytime from anywhere. And by doing so, they create confidence with the platform And that eventually translates to trust. And the more they trust the platform, and the more they trust the data that's available on the platform, that is a win for us. And this is what we wanted to ensure that's actually achieving. Now, there are many different perspectives when it comes to considering what you need to achieve in order to build a very democratized platform. But the goal is the same, democratization. So from an engineer and data engineer point of view, they want it to be simple, versatile, and have the ability to connect to as many critical data sources as possible natively through the platform without utilizing any other systems. From a self-serve user perspective, no matter who that user is, either as a data engineer, a data scientist, a product analyst, a product manager, a financial partner, no matter, what they need is easy access. And what they want it to be is easy to use. And when I say easy to use, it's not because the UI is nice or the data is so simple. It's because there is a plethora of information available for them to access so they can troubleshoot any challenge they come across, or because it's so easy for people to enter, where actually we end up creating a data community within an organization. And by having this feel that there are so many people in the same way as you, where they try and they learn, you feel that there is support around you. And that a feeling of support also gives you the feeling of an easy-to-use platform. Eventually, the other most important thing is that all our users want to have everything in one source. They don't want to deal with different database connections. They don't want to deal with the files flying around. They want everything in a single location. And from a business perspective, we want it to be modern and relevant as much as possible and open to emerging technologies and compatible. We want it to be secure and, of course, as cost efficient within the constraints of the complexity of the environment that we have built. So let's start looking at some of the user stories. We will start with the data engineers, since they are the people who are building the platform. Always our goal was that we want to have cross-cloud connectivity so that we can work with data from any cloud anytime. Since as a business, we're operating in both clouds, GCP and AWS, primarily the data platform is on AWS, the goal was how we can easily connect to all the different microservices and critical data sources that we deploy on GCP. And we wanted all this to become available through a single workspace with the goal that we simplify our architecture, we simplify our code base because now everything can be queried with SQL, but also we have everything available to connect, to interrogate, to analyze, even before it lands on a lake and becomes a managed table, for example, for our users. And Starburst, this is the core philosophy of Starburst. All your data in a single location. And this is perfect for us because we have exactly the same philosophy when it comes to our data architecture. The second most important thing was that we wanted to make our processing as simple as possible, and we wanted to be SQL first because we want to maintain it easily, but at the same time, we want to democratize our code to our users. Because when we build the platform, we didn't build it for data engineers. We built it for our end users. And since our end users are SQL users, it was very important for us, all our code that reads data, transforms data, processes data, materializes data in any form, any business logic, it's only in SQL. Because as we code our solution and we're preparing our transformations, that code becomes a documentation and knowledge for our users. And it was very important to keep on track with this philosophy because the goal was always to democratize the data. And having SQL code democratized for our users gives them the opportunity to understand what functions are we using, how we have defined specific business logics, how we transform data, where the source, where the data is coming from. And this particular philosophy of ours has enabled something critical that you will see in a bit. The last user story for today, for data engineer, is that, all right, we have opened up the platform. Now we have hundreds of users writing their own SQL scripts and hitting our clusters. But how do we maintain cluster usage control and health? And through the routing rules from the Starburst platform, any data engineer has the ability to create rules, reorder rules, adjust rules as they see fit, so we can direct queries running by specific user roles to specific clusters. This way, we control the usage, and at the same time, we control effectively the cost. Let's move to self-serve user stories. As we open up the platform, we have lots of people trying to achieve exactly the same thing, but with a very different SQL code. So this is beautiful from our side because we can see how people try to solve their own problems and gives us inspiration on how we can potentially try to standardize a few things. But what it creates is inconsistency. So in order for us to provide an easy environment for our users, we have to come up with solutions to allow them to perform repetitive operations in a streamlined form by creating custom SQL functions. I have two simple examples for you, nothing groundbreaking. But for example, we're dealing a lot with telephone numbers and we wanted to be in a specific format, so we developed the clean phone number function. Or for example, we're dealing with a lot with emails and we want to ensure that the emails that we have the correct format. We have created the isValid email function. Now, what this creates is, of course, we give a much simpler solution for our users to use moving forward. At the same time, simplifies our code base because we streamline repetitive operations. And also, when someone reads the code, it's much simpler to understand what it does. The next important self-serve user story is that up to very recently, all our self-serve users wanted to combine data that they have and collected by themselves, either by acquiring them from third-party sources or whatever, and they wanted to connect it and analyze it alongside anything else we have on our platform, not only data on the data lake, but for any other source of data that we have connected with Starburst. Before, that was a bit of a cumbersome task, and always a data engineer had to be involved because we had to take the data set, upload it to an SFTP, make it land on our S3 buckets, then write a script to materialize it, make it available, load it, so on and so forth. Now, this is a task that, of course, provides value to our user, but it's not a valuable task for a data engineer. So what we have done is that we connected Starburst with Google Sheets, and now we have given the user the ability to load the dataset, whatever dataset that is, on Google Sheet, and then can query it directly through Starburst like it was any other table on our data lake. They can apply any function, more or less the same functions that we apply anywhere else. They can transform it, they can manipulate it, and they can combine it and analyze it across any other thing. Now, the important thing here is that we improved the functionality. We eliminated data engineering to be involved in this workflow, and we have given the full power back to the user to do whatever they like, which of course increased speed and made them self-sufficient. The next one is also about connectivity. You will realize potentially that the theme of today's presentation is all about connectivity, and there is a very good reason for that. We have another type of self-serve user, this time the engineers, who are building microservices, they're deploying databases, and they collect a lot of data that are critical to us. What we have achieved with Starburst is exactly the same thing as with Google Sheets. We have connected all the databases that we develop internally, and we made them available through the Starburst interface. We are not connecting directly to the pro databases. We are using data migration services to copy the data real time and provide to our engineers a safe one-to-one environment to use it as a sandbox for them to analyze, understand what is happening with the databases and the data they collect, combine it with other data sources, and try to troubleshoot in a much more efficient way. Now, even though this is a very simple concept, what has actually helped us achieve is that we destroyed the barriers between the engineering workspace and a data engineering workspace. We have invited all our engineers on Starburst. They have access to all the data. They can analyze it in a way that we can fully understand, because every time there is a challenge or they try to get to somewhere, the context that they provide to us or any data user of the platform is context that we can understand immediately and we can action upon it. And this is extremely powerful because it has created much stronger collaborations, better relationship between the various parties and data users of the platform. And of course, we are dealing with any issue or discovery much more efficiently than ever before. And this has completely revolutionized the way that we operate as different teams within the same company. Now, let's look a bit of a couple of user stories from a business perspective. Not so much things that business user will execute, but requirements coming from the business. So any business these days wants AI everywhere because we want to be more productive. And it's great to see that, for example, Starburst offers a lot of different AI features already on the platform. And if you watched the event from last week, you know what to expect and what's coming in a couple of months. But the idea was that when the businesses want AI everywhere, primarily what I mean is that I want to be able to test and experiment and explore with any technology possible. So currently, since we're on AWS, we have a particular Airflow pipeline that takes data from a data lakehouse, sends it to a Bedrock agent. We apply any form of classification, for example, or contextual analysis, and then we send it back to the data lake. We store it, we materialize it in a table, and users can analyze it further. But now we have use cases and requirements for people to use Vertex AI or Gemini or any other technology on any other cloud platform. So how can we achieve that without increasing complexity? We have done exactly the same thing. We integrated BigQuery with a Starburst, a solution and technology live in a completely different cloud from a data platform on a completely different region. And now very easily, we can write and read data from the data lake direct to the BigQuery with just a SQL script. It doesn't need any more for us to build complex Airflow plugins, manage lots of different types of code, to be able to satisfy lots of different use cases. We can very simply write any data to BigQuery and then give the user to take the data, connect it to any Vertex AI model or Gemini, perform their own POCs and experimentation, and then write it back to BigQuery, and then very easily transfer it back to the data lakehouse. And our users can do this completely self-serve. Not even a data engineer needs to participate to copy data to BigQuery so they can move on. And this is the power of being available to be in a multi-cloud and perform across multiple clouds, because you want to have the ability to test whatever becomes available as quickly as possible. And when we have proved the concept and we are ready, we can then fully productionize it. The last user story for today, I would like to remind you what we discussed a bit earlier. Everything needs to be SQL because our users are SQL users. So by having everything in SQL, because of the connectivity that Starburst provides us, where we can query any database, any data source with SQL, because we have the ability to bring everything and transform everything with the power of Trino with SQL, we never had the need, at least at this point, to utilize any different technology. SQL was more than enough, and the power of Starburst and the power of Trino was more than enough to process all the data that we have. So since all our code base is in SQL, and since we democratized completely our code base, we have deployed LLM chatbots that we fed into them our full code base, additional documentation from Confluence and GitHub, and now our users can ask simple questions about everything related to the processes, the data transformations, modeling, definitions that we have available on our platform. This example is someone was asking what is a test account and how it's defined, and the answer that has come back is a lot more context with SQL references from the code base that now a user can take, use it in their own code, play with it as they like, and it's fully around our user base, which is primarily SQL, but more or less anyone can use it within the organization to extract knowledge from that. And this is also another extremely powerful user story. So to summarize, Starburst has enabled us to simplify our architecture, processes, and how we connect to critical data sources. It has allowed us to unify our data, our code base, and our knowledge base so we can easily externalize it. And of course, it has helped us to democratize access to our platform, enable innovation, and fast access to insights across lots of different personas and users. And on top of all of that, we have achieved an incredible performance gain, especially for our daily batch pipelines, where we have seen 60% and over 60% reduction in the time required to execute them, but also because it's such a safe environment for our users to experiment freely without any constraints. So I hope you find this useful, and I hope some of our user stories are very relevant to your environment. So thank you so much for your time, and we're here to answer any questions.
Thank you, George. That was absolutely fabulous. Well done. It was super interesting. Democratization, right? The word of the day. A few things I picked up. In just 1.5 years, you enabled 30% of your business to run SQL analytics using Starburst. It's super impressive. So well done on that. I also really loved how you shared about Starburst helping you unify over 100 disparate data sources, supporting your multi-cloud strategy as well, which is, of course, something that a lot of businesses are now considering as they expand globally, and also about reducing your pipeline execution from 6 hours to 1.5 hours. So super impressive. Well done to the Checkatrade team.